Okay, hello everyone. In today's talk, I'll take you in a short trip to how we plan to navigate the transition from classic Solidity to core Solidity. First, a little about me. I'm Kamil. I'm from the Solid compiler team. I've been in the team since like 2020, and for some time I've been co-leading the team with Daniel Kirchner. We have recently transitioned from Ethereum Foundation to Argo. The structure is more flat, so the responsibilities got more dispersed. My focus is I'm working mostly on core Solidity, and my current focus has been on roadmaps, designing classic Solidity, and getting us through this transition. So, let's go. And for some context, in case you haven't noticed, we started publishing a series of blog posts on our blog. They talk about our long-term roadmap. There's one about core Solidity. I think that will be most interesting to most people here. We are planning more, and one of them will be basically about what I'm talking about, but in more detail. So if you don't catch something, you'll be able to read about it later. Yeah. So what is our goal? Our goal is to make a smooth transition and avoid making mistakes of other product. The famous transition from Python 2 to Python 3 to like the whole decade, and no one was satisfied with that. We're gonna try to avoid that. Still, we are not going for full perfect backwards compatibility, because this means keeping a lot of stuff in the language that we're not satisfied with if we want to improve. On the other hand, we're keenly aware that breaking changes will lead to friction for users, so we'll have to strike the right balance. Whether we'll manage or not, we'll see, but we're very aware of it. So I'll walk you through 4 mechanisms that will make smooth transitions possible. The first is syntactic sugar in core Solidity. The second, the possibility to converge the syntax of classic Solidity towards core a little. Then possibility of automatic translation tools. And finally, our main pillar of making the transition smooth, interoperability between the two languages. Syntactic sugar. Core Solidity is actually 2 languages in the French code. The first one is Sail. It's really quite low-level language that has very expressive type system. It provides the things we always wanted to have in classic Solidity, which is like generics, type classes, algebraic data types, first-class functions, type inference. But aside from that, it's really minimalistic. It has absolutely no high-level contract abstractions. No things like events, errors, external functions, no arithmetic operators. All arithmetic has to be done via inline assembly. No loops. The only control flow constructs are ifs and pattern matching. The only built-in type is word, which represents basically a Yule variable or stack slot, however you look at it. And it relies heavily on inline assembly to do anything. Then core Solidity is Sail plus standard library plus sugar. You can use all the syntax all Sail syntax directly in core, but you have all the code that was hard-coded in the compiler as utilities is now a standard library, and we have extensive sugaring layer that would make the syntax really close. So the language will be much closer than you may expect. Most of the features of classic Solidity will be replicated exactly in core. We expect that should make it much easier for people to transition than we expect. We do have some deliberate omissions, like inheritance, try-catch, and libraries. Those features will not come over. We have replacements. There will be superficial changes, like switch to postfix types, small syntax changes, and there will be, of course, the standard library, which all the things that were sitting in global namespace will have to be imported. But yes, sugaring is very powerful in core Solidity, and technically, if we really wanted to, we could basically port classic Solidity on top of Sail. We don't really want to, because one of our goals is fix long-standing issues we've seen in classic Solidity. So some of the things we would not translate over. Even if we translated them, we would want to remove them in some breaking release. That would be counterintuitive, counterproductive, because we would be spending time revealing them just to remove them later. So it will be slightly breaking. And the next mechanism that we could use to make language closer is convergence of syntax. We already had a lot of significantly breaking changes in Solidity. Examples like in 05 we had the var keyword that was like early version of type inference. In 08 we had like checked arithmetic. There were still conversions. Still in 05 like scoping of variables changed, which kind of is very intrusive change for language like that. We still went through them. So core will be not a big departure from that. And yeah, one way we could make the language, we could bring language closer is not only not change core, but also change classic Solidity slightly to make the syntax closer. For example, one big example we could do is like introduce postfix types already in classic in our breaking release. The question is it worth it? We're not sure. It will be less painful, but it will make the transition longer. So we're aiming not to do this, but there's a possibility. One thing I wanted to also underscore is like, what do prefix postfix types really mean? If you look at the example, it's really simple. You can have type before or after. Does it really matter that much? Turns out yes, because prefix types are infamous for causing parsing ambiguities. For example, if you look at the example at the bottom, you have S of 3, and you cannot really tell if it's like an array of 3 elements or like indexing of an array. By the way, this small mistake should be 4th element, but yeah. One way the way Solidity, classic Solidity fixes that ambiguity is basically by not allowing you to use 2 complex types. That's very limiting, and the way other languages sometimes solve this is the Lexer hack, which means they have to have this feedback between parsing, analysis, feeding information to what is what. This makes compiler complex. Modern languages don't do that. The better solution are postfix types, which means simply switching the order, which means that you know that you have the identifier in the front, you can parse it unambiguously, and that's easier. We could basically port that to classic Solidity, making the part of the transition earlier, but also allowing us to change things that would remove those parsing limitations. Okay, let's move on. The third possible mechanism is automatic translation of code. We actually tried that with utility called Solidity Upgrade. It has it's good at some things, especially simple superficial changes. Postfix types happen to be one of those. It's not so good at changes that are semantic in nature or complex. For example, we changed associativity of exponentiation in 08, which means the code that still works, but will work differently. The tool could introduce parentheses, but that relies on assuming that the code is correct, and part of the reason for such changes is to make sure you make things explicit and check that. Also, complex changes like inheritance do not have one-to-one translation, and that's usually too complex for such a tool. We had one, we dropped it in 2018. We could reintroduce such a tool, that's also an option. But yes, let's move on to the fourth pillar, which is what we are probably be focusing on. First, to make it clear, the language compatibility is something that all languages usually strive for. So, of course, you'll be able to call external functions across language. But we'll make it more interesting. We plan to make it possible to just throw in sources in both languages of the compiler, have it just compile it and give you a single output. You just have to use special pragma to make sure it's possible to detect the language. And that thing will not allow you import. You just compile it independently, but compiler manages that for you, making it transparent for frameworks, tools, which will, the main benefit will be that you will be able to make very gradual transition. You'll be able, for example, to translate contracts one by one, still having most of the project in classic and slowly shift to core. And the final thing is interoperability at the function level. This means basically allowing imports between languages and allowing you to call internal functions. This is a bit more complex. It has some pre-assumptions that have to be met because both languages will compile to you. We have to ensure that the memory layout is the same, for example, the free memory pointer, stuff like that. And there are some challenges, like you can use call blows because you have utilities in UL on both sides, and the optimizer has to make sure that they are duplicated. The function is black box to the other language. So, for example, if you call it from, if you have pure function, want to try another, you don't know if it's pure. You have to feed back analysis information back from the other compiler, from the other side. And linking at UL level has the issue that also the call is a black box, so the optimizer has to assume the worst side effects and cannot optimize it as effectively. This can be alleviated by having some metadata or annotations at linking level. But overall, those challenges are possible to overcome. This is also very powerful because it will let you have libraries that are still written in classic Solidity and have code in a new language using it all. So the transition will be really gradual and not a clean break that you have to basically switch everything. Yeah, and that's all. So to reiterate, the main mechanism will be extensive sugaring in Solidity that will make the links really close. The second one is interoperability, so that you'll be able to compile both languages in the same project and call each other's functions. And there is a number of other mechanisms we can still use to try to smooth it over in case those two don't work out. But we're very hopeful that this will be enough. So thank you, and time for questions.
Thanks a lot, Kamil. We have exactly 3 minutes for Q&A. If you folks scan the QR code on the screen, you can enter your questions. I would also suggest that at the begin, I can put the session on live. At the beginning of each talk, the session will be live, and so you can already scan the QR code and have the questions ready by the time the speaker finishes their talk so that we don't have to waste a lot of time. But if you can send in your questions. Okay, so we already have the first one. What are your thoughts on the idea that changing the syntax of the language invalidates all of the educational content built around Solidity? How will you make it easy for new beginners to use the new language?
That is a bit of a problem, but like I said, the core Solidity will be very close to, fully sugared, core Solidity will be very close to classic Solidity. So it doesn't really invalidate all the knowledge. If you are a beginner, the transition will be really easy because you'll be able to use most of the things. It's not like the whole language changing. That's the main point. The things that will be more important are like optimizations. You will have to be able to optimize differently because the code gen is different. But that are more advanced topics, and I expected expert and advanced users to be able to pick that better than beginners. So I don't think there'll be a really big problem here.
Okay, thanks, Kamil. The next question is, will we finally have switch in core Solidity?
Maybe. I mean, you'll have match, which is pattern matching, which is basically some sugar over switch. And I think that's what more people will use more. So probably not, but you have an equivalent mechanism.
Okay, awesome. I see that there aren't any more questions for now. Oh, okay. Another one came in. Is core Solidity considering the future migration from EVM to a RISC VM-based VM?
That's actually not a core Solidity concern because core Solidity is just a front end. That will be more of on the backend side. We are making some early moves towards modularizing the compiler, making, for example, to swap out the backend. We still focus on core Solidity now and new language, and still finishing the backend to make the AI pipeline fast and avoid stack too deep. So that is somewhere on the horizon, but not an immediate concern. The transition is like way in the future, so we have bigger problems to deal with first. But we're aware of that.
Amazing. That will be all for you, Kamil. Thank you so much for your talk and for answering all of the questions.